Hey guys, we're going to be talking about arguably the most kind of interesting unit, and that is the periodic table. And we're going to go into detail about each of the families on the periodic table, what kind of characteristics each family has. And then we'll talk about a few periodic trends that you can see just by looking at the periodic table. So this is my favorite unit in all of chemistry. I wish this was an actual study, but once you discover an element, there's not really much you can research on. But I'm really excited because I think you guys will really like this. Definitely an easier unit than last time and definitely less math. No equations at all, just a few things that I think as we repeat it more and as we do some practice problems, it'll be really simple. So let's go ahead and get started. There is 38 slides in this presentation. I'm going to break it up so that the videos are not too long, okay? So let's go ahead and talk about Unit 3, the periodic table and periodic trends. What are their lesson objectives for the first video you need to watch? Understand the development of the periodic table. Understand how the periodic table is organized. Again, very simple, and you guys probably already know this. And then classify elements by family name, group number, and periodic number. Again, very, very simple. So the periodic table, if you don't already know, you're probably in some trouble. But this is what it looks like. There are, as of today, 118 elements. The element with 1 proton is obviously hydrogen. The element with 118, the maximum protons that we know of, is Og, and I don't even want to try to pronounce that. So how did the periodic table become the periodic table? There were elements known before there was a periodic table, like hydrogen, oxygen, and they actually had names. And you're going to do some research on elements to find out how they're named and why they're named the way they are. But as far as putting them on the periodic table and finding a way to organize these elements and what kind of patterns they saw, it actually started in 1869 by a chemist named Dmitry Mendeleev. He created the periodic table. I think he had about 40 elements on there, but he's actually credited with creating sort of, for lack of a better word, a table that organizes all the known elements. And then between 1882 and 1945, the periodic table was edited, meaning that elements were added and filled in based on the number of protons they had. So Dmitry Mendeleev was really, really adamant on organizing it by atomic number so that it goes from number 1, which is hydrogen, all the way to whatever element is has a more number of protons. Of course, we're going to talk about, we've been talking about atomic number. Each element has its own atomic number, meaning each element only has a certain amount of protons. And if you change that proton, you change the element entirely to a different element on the periodic table. And then this term eventuality, I wanted to keep it consistent. What does the future hold? What if there's another element discovered that has more than 118 protons? There's still opportunity for elements to be added to the periodic table. This is not like a set in stone thing. And this is why we use the word development. This is not set in stone. There is always room for more elements if they are discovered. And who knows, maybe one of you will discover it just walking down the street or something. The organization of the periodic table. The periodic table is organized by atomic number. Each element has a specific amount of protons. Each element is placed in chronological order based on the number of protons that element has. Okay. So if we take hydrogen, which is number 1, atomic number 1, it has 1 proton. If you have a hydrogen that has 2 protons, you don't have a hydrogen, you have what's known as helium. Helium is the only element that has 2 protons in its nucleus. Okay, the number of electrons can change, and the number of neutrons can change, but the number of protons is specific to each element. This is how we distinguish elements from one another, especially if you're doing like forensic work or something like that. In addition to the element symbol for each element, the atomic number, and the atomic mass for each element, the periodic table also has 7 periods, 18 groups, and 10 families. Okay, I'm going to go over periods and groups really quick, and then I'll move on to families in the next video. So when I say period, I mean row. And Emma actually gave me a good technique. She said, we learned that people say period, horizontal. So there are 7 periods, okay? The first period has hydrogen and helium. The second period has lithium all the way to neon. The third period has sodium all the way to argon. The fourth period has potassium all the way to krypton, and so on. The lanthanides and actinides are actually part of period 6 and 7. So the lanthanides are part of period 6, the actinides are part of period 7. And then we go from periods to groups up here. And there are 18 groups or columns of the periodic table. Okay. So hydrogen all the way to francium is group number 1. Beryllium all the way to radium is group number 2. We can see nickel to darmstadtium is group number 10. Group number 15 has nitrogen all the way to moscovium. And then group 18 has helium all the way to our 118th element. Note again, the lanthanides and actinides are both part of group 3. This entire period is part of group number 3 for both of them. And I'm going to go ahead and stop here for now. Go ahead and answer the questions.